Okay, welcome back, Algebra 2 Trig Kids. We are continuing with 9.2, sum of an arithmetic sequence. The EQ is, how do I find the sum of an arithmetic sequence?
All right, so we're going to continue on with that. Thank you, Jane, for that intro. So right now, go ahead and write down example 1. Find the ninth term of an arithmetic sequence whose first two terms are 3 and 7. So what we're going to be doing is using a recursive formula in order to write and find the ninth term. So you guys are actually already know the formula for it, and it was given a sub n being the term that you're looking for. Okay? So we're given here that the first two terms are 3 and 7, and I can use that in order to figure out the difference. So the difference here would be 7 minus 3, and that gives me 4. So now I have my initial term and my difference. I'm going to go ahead, write my arithmetic sequence, and that's going to be 3 plus n minus 1 times 4. I'm going to go ahead and simplify this by distributing, so 3 plus 4n minus 4, which means my arithmetic sequence will be 4n minus 1. So in order to find the ninth term, all you have to do is substitute 9 in for the n. So let's make a note of that. N equals 9. Plug that right in. A of 9 equals 4 times 9 minus 1. So a sub 9 is equal to 35. Okay? So very simple, and basically you just use the given information in order to find the later terms in the series or the sequence. And the reason that this is going to be important is because we're going to be focusing on finding the sum of an arithmetic sequence, and it gets a lot more difficult when you're asked to find the first 150 terms or something like that. Okay? So let's go ahead and move on to the actual bulk of the lesson. And before we do that, I'm going to need you guys to go ahead and copy this part. So copy down this box right here where it says the sum of a finite arithmetic sequence. And this is the formula we're going to use in order to do very quick addition rather than having to add every single term that's given to us. Okay? So copy that down. And we're going to go ahead now to move into example 2. And you're going to find the sum. And some of you might look at this problem and say, wait, can't I just put that all in a calculator? You could, but the whole point of this is really to use that formula and practice it so that we don't have to enter all of these numbers in. So plus 17, plus 20, plus 23, plus 26, plus 29. Okay, so it goes all the way off the paper. And you could enter it all in, so 2 plus 5 plus 8, so on and so forth. But the formula makes it so much quicker. So in order to use a formula, the first thing you need to know is how many numbers are there in this finite arithmetic sequence. We call this one finite because it's only starting with the initial value and it ends at a certain number. In other words, it doesn't go on and on forever. So this finite arithmetic sequence has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 terms. Okay? So using that formula, we had S of n equals n over 2 times a1 plus a sub n. We're going to go ahead and substitute these values in. So S of 10 is equal to, we plug that right in, 10 over 2. Initial value is 2, and then we add it to that 10th value, so 29. And then we go ahead and simplify. So 10 divided by 2, simplify that to 5. 2 plus 29, that's going to be 31. And the sum of these 10 terms is going to be 155. For those of you who don't believe me, you can go ahead, plug all of those into your calculator, and chances are you will get that. So let's go ahead, use that, and now go on to a little more of a challenge with example 3. So with this one, we're going to be asked to find a far more difficult sum, and it's going to be based off of this idea that the numbers just go on and on forever, because really these numbers do go on. So find the 120th partial sum of the arithmetic sequence. Okay, and we're going to go ahead and list out the numbers that are part of this sequence. So 8, 20, 32, 44, 56, 68, dot, dot, dot. In other words, this sequence is going to go on and on forever, all the way to whatever huge number it ends up as, so we can assume infinity. But we're only asked for the 120th partial sum. In other words, we want the sum from the initial value all the way to the 120th term. In order to do that, we want to use that formula rather than having to add every single one of those numbers, because adding 120 numbers is going to take a bit too much work for me. Okay, so let's go ahead and take our information first. So a sub 1, our initial value, is 8. To get from 8 to 20, I see that our difference is 12, and double checking just to make sure. It does look like we go up by 12 every single time, so we do have an arithmetic sequence. So our difference here is going to be 12. Now, in order to use that sum formula, we do need to know what that 120th term is. So let's go ahead and first write the general sequence for this. So a sub n is going to be equal to 8 plus n minus 1 times 12. Simplify that, we get 8 plus 12n minus 12. And then all the way down, we have a sub n is going to be equal to 12n minus 4. So to find the 120th term, just like in example 1, we're going to plug in 120. So 12 times 120 minus 4. So 12 times 120, that's going to be 144 with a 0, and then minus 4. So the 120th term in this entire sequence is going to be 1,436. Okay. Now, that's not actually the answer we're looking for because we're asked for the sum, but this is going to be important for us. So the sum of the first 120 terms, we're going to substitute in 120 right there, over 2. The initial value is 8. We're going to add it to the terminating value of 1,436. Simplified inside and outside, this is going to be 60 times 1,444. Crunch that in your calculator or by hand, and you get 86,640. So if you were going to add all of that by hand, that's the answer you would get. And I'm sure all of you would love to do that without a calculator. So make sure, memorize this formula, and go ahead, rewind, replay, watch whatever you need, and move on to the Google Forms. Have a good day, you guys.